Hello everyone, welcome back. In this video we're going to go over the design of Slab in Etabs. Now designing Slab in Etabs required some additional information. Now in order to understand this topic you should have finished structural analysis 2 in order to understand the way that we're designing Slab by hand. Now Etabs has similar methods, which we call design strips, column strip, middle strip, or using finite element method. Now, in order to do the design in Etabs, so I'm going to keep this one simple, I'm not going to go into detail of it, leave for the students to decide whatever they want to do. By the way, this is a bit changed because of the auto selection. So don't worry about these things changed here. It should have been as the previous one because I used auto select design, the columns changed. Now, in order to do the design, so that's basically you run the analysis. In the design, when it's come to design of a concrete slab, there is a part which we will define whether to design over strip based or finite element method based. So the way that we're designing the slab will change. Now strip based, it's kind of, if you remember from, you will divide your let's say this is the column strip, there will be width for it. So sorry, let's make it, well, this will be the column strip, so there will be a column strip here. In between them will be middle strip. So you will define the strips. This is the column strip, column strip, column strip. Maybe you'll add a column strip here, or the column strip here. Here you'll add another column strip. Whatever the case that you have it, you'll add column strips, and there will be middle strips as well. So there will be middle strip, column strip. This is what we know from normal design. So the column strips and middle strip, they have length according to the, here it's irregular shape, we have it here. That's why if you do it by hand, it will take some time. So will you be able to do it? You'll be able to do it. So I'm going to show it to you how to do the design by column strip, and the next one will be flexural design strip. For finite element method. So in order to do this one, there is a way that we can allow Etabs to define the strip for us, but it will be a bit messy because in the case we have it here, we have a lot of grid lines, so it's recommended to draw by hand. I'm going to show you both. I will not make you responsible for the design in case if it is like this. Always allow you to define automatically. So here in an edit tool, remember this is unlocked, so I haven't still do an analysis. Let's say that I haven't done analysis. I want to do strip. If you run analysis, automatically Etabs will use finite element methods. If, for example, if I don't do this design, it will go for run analysis, it will do finite element methods. If I'm going to define this strip here, so I'll add edit design strip, add design strips here. This is automatically. We'll choose a story, let's say this is a ground floor. Then we'll add design strip along the grid lines, since we have a lot of grid lines here. And this will take some time, and we'll choose which one is the best. Then we have middle strip. We're gonna add middle strip as well. Now the direction here, we'll choose X, and layer can choose A here. It's basically in the X direction layer A, in the Y direction we'll choose layer B. So in X direction layer A. The strip width, I can specify it fixed, or I can let Etabs to decide the strip width. So if I select this one, you press apply, you'll have some strip on the drawing. Now here, for example, it didn't add the column strip, it automatically will try to add only on the grid line. Look, there is no grid line here, so it will not add it. Only on the grid lines, we'll try to add, like over the grid lines, this column strip will be added, and in between them will be what? Will be middle strip. Is this what you want? If this is the case, then you accept it. Look at here, or maybe we need another column strip here. I have to add it by myself. So auto works with the symmetrical buildings. If you have symmetrical building, this is the best case scenario, the best option that you can use it. Why? Because over the grid lines will be added a column strip. Well, a Control Z, I'll just get rid of this one. Now if I go for the Y direction and I say, for example, B, what will happen over all the grid lines? Whatever the grid I have it here, the grid lines, it's gonna add a column strip. Is this what I want? For example, is this gonna be column strip for me? Oh, this is the problem we have it in asymmetrical buildings, that you cannot just simply say, okay, this is the column strip, it's the middle strip. For the symmetrical, yes, even in the reinforced concrete design, we'll say that the column strip, middle strip can be used in the case if you have, for example, minimum this much amount of slab beside each other, and the difference between their dimension is within this ratio. Then you can use this middle strip, column strip. I have to show it to you, and needs to know how to do these things. Well, if you don't like this way, if the automatic does not work for you, you have another way to do it, which in a draw, you have draw strip design. Here you are deciding the section. For example, let me to do for one of them. Let's say I would like to do for this case here. Let's say I'm going to do for this slab here. So what we have here, it's a strip. Let's say strip A on the direction of X. Column strip. The width of it I can specify. So to the left, to the right, basically end with, start with. This is if it is a kind of, you have 4 values you will deciding it. So the start to the right, so 4 points you have it. And where you draw in the middle. So you draw this line, the red one, and it will take distance to the 4 points, which we have it here, 1500 to each direction will go. So I'm going to decrease this one, maybe to the right will make it 0, so I can make this one 0 here. From start to the left of it, so if I'm drawing from that side, it will be to the, okay, it will be 0 from here, and with the gate to the left as well, I'll make it 0, and let's say it will be 1500. If I start, for example, drawing from this column to this column, press escape. Now I have a strip. This is a column strip, I have it here. Now if you cannot see this red one, it's most probably because of other assignment here. You should show width of the design strip here. You can even show the labels, whatever you want. This is if you check this one, show width, you will see the width of the column strip. Now I can continue this way, add whatever the column strip, whenever I want, wherever I want, I can add them according to what you know from the reinforced concrete design. Now how much is the column, for example here, what will be the column strip, where is the column strip here? You can add this one, but it's recommended for the symmetrical buildings. For unsymmetrical building, this method will not work because you don't have column here. For example, there is no column to connect it to say, okay, this is the column strip, we have it in between the middle strip. Or in the case we have it here, the space opening, we have a lot of problems that this method does not work in the case of unsymmetrical building. So I'm deleting this strip, I'll leave this one for those who are interested in the case they have symmetrical buildings. So let's say that I'm not going to go for design for the strip in that case. We're going to go for the design of finite element method. Now, in order to do finite element method, so you have the analysis. So you run the way that we should do it for. Let's discuss this one. We said meshing is one of the option in that Revit is going, Etabs is going to use in order to mesh the slabs that they have. Now, by default, before analysis, we discussed this one. We have meshing for floors. It can be general mesh, it can be rectangular mesh. You will decide this one. This is if you leave it for Etabs, it will find the best, for example, meshing. Maybe it's not going to be rectangle. If you've seen the analysis before, you've seen that there will be irregular meshing. It's general meshing, automatically will take it. Or we say we can, for example, if I have this, I can even assign a meshing that I want to. So from here, we have floor mesh options. I can decide what I want here. I can decide, for example, whatever I want. For example, I want to mesh this one to 10 by 10, 100 smaller sizes. This is what finite element methods work. It will divide these into smaller options for the designing. So we'll leave it as default. If you leave it as default by itself, it's going to take general things. It's going to take, because in analysis we select this one to be general. So if it's general, it will take general. If you make this one rectangular, what will happen? You'll see that the mesh distribution will be a rectangular base. If it is general, it will take it by itself. It's more appropriate for the cases when you have irregular slabs, because in irregular slabs, Etabs knows better where should be the meshing size. Look, the meshing here is like this. So this is rectangular mesh will look like. Like it assumes that this is the deflection will happen on this line here, because those line will be assumed as a joint rotation deflections in the analysis. If you leave it for general, so I'm deleting this one. If you go for analysis, and we already discussed this one to be general mesh, in the general mesh what will happen is Etabs is deciding where exactly it's supposed to have more mesh in the location when there will be a lot of load around it. The others will make it larger. Automatically will decide the shape of the meshing. Irregular meshing will be used here. Now, irregular meshing, it's way different. So the design of this one here, will be area per millimeter square. So you will see this one now in the design. In the finite element method, the design of slab will be different than the column strip and middle strip. I will show you an example for the middle strip, the one that you do it in reinforced concrete, that if you use middle strip, column strip, you will see the top bars, bottom bars. But in here, in the finite element method, we're not going to see this one. We'll see it as a total area, for example, area required per meter square in the design of slab. So let's say for this example, I have to go with this one because we have irregular slabs here. So this is whether you choose this general meshing or the other meshing, doesn't matter. General meshing is more appropriate because Etabs will find the best places for the meshing. Let's say those are okay here. We're gonna go where design. Now we have concrete slab design. The same thing, we'll go revise preference, view revise preference. So this is the cases that we have it here, the code. And then if you have cover of the slab, minimum cover from the top, 15 millimeter, if they can change those things, you'll be able to change it here. The preferred bar size here, let's say I'm gonna go for 8 millimeter, like it will be red here. It's different than the beam. Let's say for the cover, I'll make it 20 millimeter here. 20 millimeter. Red means that we altered them. So this one, layer A to be the inner slab rebars. I'll choose it this way. Let's say this is the preference I want to have it here. This is the code. Press OK. It will take those values I wanted there. Now, go back to design. By the way, you have the same thing here. Instead of going there, you have the same thing here. This is slab. Then you'll select a story before, let's say, combination. Now, the design combination we have for slab, all the design combination for slab here. Those are for slab, so that's okay. Then we will go select story for design. Let's say in case of designing slab in a multi-story buildings, you don't need to design whole stories. If they are the same, you'll just choose one story to design here. For this case, I'm going to choose the three of them. Floor, first floor, ground floor, landing. for designing. If you have multi-story and you have most of them similar, you will choose just one of them because it will save you a lot of time and generating a lot of data. By the design, you will just make your life easier. Well, let's say just I'm choosing ground floor. Any of them can be. We can choose more than one. By using shift, holding the shift and click, you can select more than one. Here I told you select master story, select all as well, clear all, you have it. Press OK, now you selected that. Then you go for start design here. Now we didn't draw a strip here because of the irregularity of the shapes, so Etabs is going to use finite element analysis to do the design. We have it here. So this basically will show you bottom rebar intensity. We have it here. It's millimeter square per meter, direction 1. We can go to change this in the design. We have display flexural design. Then from here I can change this into top bar. This is based on the finite element. We didn't have strip design, we only have this one. This is the flexural, we have it here. So there are things that you can change. Define bar size and by spacing, or bar area, bar spacing. For example, bar area. So when you use, for example, you can change these things a little bit this way here. The two direction you can do, for example, show the values that you want to. Now, in the finite element methods, basically this is kind of zero minimum we needed here because there is no load over it, so it came out to be minimum. It's zero basically, minimum required here because it's written that it's a kind of /0, it's minimum. Additionally, you can add 6 at 12 millimeter. If you have a lot of load, you will see different values there, different values for the per meter square, because in finite element methods, you're not going to get the way that it's the bar direction because it's irregular. We have it irregular, those meshing, so you won't have something, you will get it per meter square in the direction. Let's see if you can display the more things in the design here. So in the slab, go for flexural design. So can we have the minimum design if it is required there, to see if it's going to show it to us minimum design. So the contour we have it is from 0. I think this is what's better here. Yes. Okay. So applying OK. Press OK. I'll just change some of the views. Now this is indication of the location that you might need more reinforcement. So this is basically reinforcement millimeter square per meter. Like according to the closer to the columns, for example, you need it. This is the top rebar intensity, the location that you have top rebars. You know that from the columns, wherever reach to the columns, you have these rebars. If we change this one, when you design and display fractional strings, I'll keep this one, let's say for bottom rebars, this one to be none, let this one press apply. In this case, it has to show us for the places when we have the bottom rebar required, and we know that the bottom rebars will be where? In the middle. This is basically the area that required. For example, 459 millimeter square per meter. Or you can just go over the things and you'll be able to find how much you need it here. So in this way, but this is finite element method, remember. If you have if you can divide this into a column strip, you can see much more conventional way of designing that you've seen from the textbooks from outside. But this is how would we use this design outside? We'll basically take the value here, for the value that we have it here. So if I take the value, then I can use this value to exactly say that this much amount of reinforcement is per meter square. Then I can find the area rebars by myself. I can find the area, whatever I want by myself in that case. It's possible to do this one manually to find the area. Then we'll say, okay, we'll define this at the bottom to be this much. This is this direction. You can go display the other direction as well. This is direction to top bar or bottom bar, similar way. And you'll be able to see this is the other direction that we have it. You see when exactly you want to. This is even the landing you have it there. You'll be able to see where this is the bottom bar intensity required there. Since you don't know too much about finite element design methods, I'll just keep it this way here. Maybe another video to show you a simple strip-based design in a more symmetrical drawing. It can be useful to see the reinforcement detailing for the slab as well, not just as area here per millimeter square per meter, no, as in the diameter. For example, you can see the rebars over them. It will be beneficial if you see that one as well. So I will stop here for the design of slab, and this basically will be our design here. I might do smaller videos because for this case we'll just only have wrapping the report. The rest of the things will be general for all the cases. So this is basically what we have it here. We'll come back to detailing later. Thanks for watching.